Morning, everybody. It's always a pleasure to be here in Bangkok and always a pleasure to be able to speak with you. My topic today is going to be about the future of AI is open. So before we talk about the future, I usually like to talk a little bit about the past, a little bit of history. Omnibus ex nihilo descendas suffici unum. Everything can be derived from nothing. One is sufficient, or one is enough. That's what Gottfried Leibniz actually said when he published his paper on binary system back in, I think, 1679. He said that to describe the binary system, he's a religious man, he said, you can derive everything from nothing, which is zero, and from one, God, which is one. Now, he probably didn't realize that binary system that he described. And in that paper, he described the conversion from decimal numbers to binary numbers. He also described a number algorithm that allows you to manipulate binary numbers. Basic algorithm like subtraction, addition, multiplication, and division. That formed the foundation of our binary encoding system today. Today, we can use binary code to represent all data, be it text, numbers, sounds, image. By doing that, we can manipulate those data and create new kind of representation in our modern computer systems that let us drive different insight, complete tasks that we couldn't do before. Ones and zeros are representing relational data. And without relational data, we're not doing a lot of banking processing today. Without relational data, we won't be able to do customer segmentation today. We won't be able to relate information together. That data can be transformed and may be represented also in a graphical format. Graph data can be used to do fraud detection, can be used to understand social media, different representation of the data set. And data can also be represented in spectrum, in frequency, right? And it has the ability to drive, perhaps, help you know the cyclical nature, repeating patterns that happens in time that isn't so obvious when you're looking at the data in time. But when you look at frequency, you see it very easily. Now, a couple of years ago, I would say probably in the last 5 years, emerging is this new representation of your data again, and this time something called foundation models. Foundation models was first coined by Stanford University back in, I think, 2021. Now, if you think about generative AI, and generative AI today is completely based on foundation model. 2021 didn't sound like that long ago. Right? There's a lot of innovation that's been happening. And in that model, there's some new things happening. And it's probably first started happening with Google. They were trying to solve a translation problem. So what they did was they took data and started out, could be sentence, right? And they begin to tokenize. Break down a sentence into bits and pieces, smaller segment of a word, perhaps a sentence, perhaps a phrase. And once it's tokenized, it converts it into a vector. Now, that vector can also be used to represent code, can also be used to represent images. There's really no limitation in that space. And why they did that was because by converting into a vector, that data can be understood by neural network. Now, during the training stages of any foundation model, that vector passes its way through multiple layers of interconnecting node. Now, those nodes starts out with parameters in them. You can think of parameters as weighted multipliers. These parameters are node by node connected together through this neural network. They start out being random. But during the training stages, these tokens, which are sequence of words or sequence of pixels that goes into the neural network, begins to combine and recombine with each other. And in doing so, it impacts the weight of the individual nodes. That's what training does. It changes the value on those nodes. Now, that network can then capture the patterns. It can then accurately predict what comes next in a sequence of tokens. And that's what gave rise to all the ChatGPT of the world and so on and so forth, to be able to take a seeding sentence, either create an entire book, a novel, take a piece of music, write the rest of the song, take a sentence, convert it to a picture. And the power of foundation model really came from the scale of the data that it can capture in a relatively small space. Now, it's not storing all the data, but the foundation models inside contains the relationship between the vast data that it's trained with. All the pattern, all the interconnection are built into that connectivities. That's where the power really comes from. Now, on top of that, multimodality, the ability to use language and pictures and sound together in a single model, making it possible for computer to appear much more human-like, mimicking perhaps human creativities. Now, from that side, though, what's really ironic and interesting is this particular observation. Over the last 2 years or so, 2 to 3 years, virtually all public information available has been captured in foundation models. ChatGPT probably contained everything and anything you need to know up until this point in time. Now, it's critical to think about this one first for a second. Foundation models, as good as they are still frozen in time. It only knows what it was trained with. It won't know anything that come in the future. So that's one thing to remember. Second aspect here is that these foundation models, unfortunately, contain less than 1% of the world's enterprise data. Less than 1% of it's actually comprised of the enterprise data. So what does that mean? It means that it's great as a commercial product or a consumer product that you can use at the consumer level. But can you use this model as it is to drive value that is distinctly yours, built on data of your company? Well, the simple answer is it's not incorporated, therefore it doesn't know about it. You cannot do anything that it doesn't know about. So, as technologists, here's our big mission. Our big mission is to get enterprise data into the foundation model so you can unlock that value, so you can drive that differentiation, make your business stronger than your competitors. How do you do that? Well, in the IBM picture, you can look at it as 3 distinct steps. One, you got to pick a base model to start with. There are people that build model from scratch. Not too many companies will do that because extremely costly and you don't have time or the data to do it. Why rebuild something that's already been incorporated? So you got to pick a model to start with. Then you got to introduce enterprise data representation from your own company into that model. And finally, pick that model and allow your company to use it. So let's step through the steps and let's figure out how to innovate with your data using generative AI. That's the topic here. Number one, you need to choose your base model very carefully because you're about to take your data set, mix it with that foundation model's data, and then build a brand new, modified, new and improved models, new LLM, large language models, that you'll use to complete your enterprise task. It may be answering questions from your customer, it may be answering questions from your legal department. So you need to know what's in it. Key things here, those models that you choose, whatever it is that you choose, has to have the performance and transparency. You need to know what's in it. Because the other main reason being, you need to have broad commercial rights to use that model. Don't spend the time building on a model that you have no right to actually use because of copyright issue that you're not indemnified for. Those are the key things. So if you're going to invest the time, choose a smart model. And I would say, because IBM is here to talk about IBM technology, pick Granite. Build on the Granite model set. So what's Granite? Well, Granite is a series of foundation models that IBM has released over the past few years. And in total, up until now, we have 18 models that's released. Now, I mentioned before that the representation of data is not limited to text. You can do different things with foundation models. You can generate pictures. You can generate various aspects of things to solve particular problem. You pick the problem that you need. You pick the solution that you need based on the problem that you're trying to solve. Granite comes in multiple flavors. Language models. Our language models are built on the language of business. It doesn't contain extraneous, irrelevant information. Then we have our code models. Our code models are interesting because our code models are built for 116 different kinds of programming language. And that data also, we are guaranteeing indemnification from copyright issues. So if your programmers are going to use foundation models and generative AI to build code, it's much better to know that your company won't be exposed to copyright issues because of the code that it was generated. There are some more interesting stuff like time series models. Time series models uses transformer to help predict demand in the future more accurately. Use electricity, for example, to be able to build a more accurate demand prediction with less data means less wastage when it comes to fuel cost. It's actually moving away from customer care, moving away from simple Q&A, taking foundation model technology and driving better profit. Right? That's the transformation that a lot of companies are interested in. And geospatial information, image, more accurate prediction of weather, precipitation to help with farming. So we say start with those. Now, topic was AI, future of AI is open. All the models I mentioned here are open sourced and available in Hugging Face for you to download and use. You will know the code and you know the model data that goes into it. And I'll explain why that is crucial. Step 2, how do you get, and this is a tricky part, how do you get your data into that model so you can start driving new values and new use cases? Let's take a look at what we've been doing up until now. Foundation models been out. One of the most famous way to use foundation models or large language models is RAG, right? Something called retrieval augmented generation. I mentioned a large language model, a generative AI, will not know anything that it hasn't been trained with. Clearly, it doesn't contain content that is proprietary to your organization. Also, it's quite difficult to retrain a model because of availability of GPU hardware and so forth, and the cost. So up until now, there's an application design pattern called RAG. And what you do basically is you manage a knowledge base, you search the knowledge base for the information that you actually want, then you pass the information into the model for it to summarize. The difference here is you're relying on whatever's in the model, so the languages in the model, the patterns, the writing style, everything in that model. There's no way that you can change the model's behavior. You're simply passing the text to somebody external to your organization and have them summarize it for you. It's not speaking in your voice, perhaps not using the exact language that your organization use. So there's some shortcoming, but it's actually a great pattern to use today. The second way to do it is you can actually take a base model and fine-tune it. In this case, you're actually adding to the base model and changing the weight of those neuron, those nodes. You're actually altering the foundation, the large language model itself. Now, it's great, but it's costly. It's requires quite a lot of data that you have to curate. And on top of that, as you train one model to become better at certain things, you give away some of the generalization capabilities. So now you have to train many models, and you have to create many instances of them to actually do the task that you want to do. Now, this is where kind of IBM came in, and there's a second piece of information, second piece of technology that I want to share with you. We got the Granite models that I think you should choose. Second is, we actually invented, our research team has invented a brand new methodology to train LLM. And we made that open source so you can collaborate around it, right? And we made models learn, we made AI learns the way that, similar to the way that humans do, based on knowledge and skills. And we allow that model to learn incrementally, a little bit at a time, not a massive model retraining. So how do we do that? Well, let's take a look. The technology is called InstructLab, and this was announced in Boston about 2 weeks before Think in the Red Hat Summit over there, back in May, I believe. And InstructLab is what we invented to do this. And I repeat once again, this is about bringing your enterprise data into a foundation model so you can leverage the power of that model to drive business value. It's important because that's what you're doing at the end of the day. So the entire InstructLab concept builds on this concept of taxonomy. And taxonomy is a tree that describes the different skills and the different data that's built into the foundation models. So if you're taking a look at foundation models like Granite, since it's a language model, it probably can compose words, can write things, freeform. You type in something, write me a birthday greeting from my mother. Well, it will write a birthday greeting for your mother. That's free-form writing. And perhaps it can do something a bit more specific, like generate email. And maybe to be able to write it in an informal tone, right? That's the taxonomy. What is the skills that's there? Now, leveraging this concept, we can use the Instruct Lab methodology to teach foundation model new things. So how do we do that in Instruct Lab? Let's take a look at this. The collaboration is simple. In Instruct Lab, let's say you've discovered a new use case that you want to use a foundation model for, except that use case doesn't perform quite so well using the out-of-the-box solution. Maybe it's a Q&A type scenario where you need to respond to customer inquiry emails about support policy. You need the policy in there, and you need to write it in a particular tone. So how do you do that? Well, in Instruct Lab, what you would do is you go into the taxonomy, you identify an area where there's a skill gap. So you want to teach it new things. When you get there, you take that note, and you add some new leaf notes to it. And you say, I want to teach you some new skill foundation model, and that is how to write email with the enterprise style that I want. You attach 3, 4, 5 examples of what that email might look like. You submit it back to your team of experts, your AI engineers, your CISO. Everyone will review and say, OK, that looks good. Those emails are not problematic. Let's pass it to the back end. In the back end, what the actual system is doing is taking a set of knowledge, could be documents, could be whatnot, maybe the policy document itself, taking the sample email that you sent. Together, it passes it to what's called teacher models. And the teacher models are now generating new test data, synthetic test data. And generating that test data, after the generation is done, it uses that test data to train and incorporate the new knowledge, the policy manual, for example, into the model. And incorporates the writing skills, the particular styles that you want, into the model. The newly trained models will know how to answer the questions, your enterprise data, and will answer it the way that your legal department, your marketing department deem to be the correct tone and manners. That's what it does for us, right? Now, let's talk about a little bit about a case study. What happens when you actually used it? Because we actually use all the technology that we built. So from that perspective, we're going to look back, and when, to last Christmas, I believe, our research team just about completed the Instruct Lab, I guess the first cut of that particular framework. And at the same time, we were building a new product. We're building a coding assistant that helped customer turn COBOL code into Java code. So far, that team has spent 9 months iterating and fine-tuning with the traditional way to get the model to understand how to convert COBOL code to Java. So we said, well, why don't we use Instruct Lab and see what happens? Right? So taking that base model that understands 116 language and try to teach it to convert COBOL to Java. Right? So what happened was, in Instruct Lab, we gave it some knowledge. 8 books, public books in COBOL, 1 programming manual from IBM itself, 1 book from that knows Java, then turn around and give it some skills, examples of how to convert code from COBOL to Java that we have done in the past. Then we give it to the teacher models. The teacher models generated 20,000 odd synthetic pieces of data. Use that data to train the original COBOL, the granted code models. Out come a brand new one. That brand new models, single iteration, 1 week of training time, improved the accuracy of code generation by 20%. Something that our team has spent 9 months building, 20%, 1 week's difference. That's what we're really kind of talking about. That's the kind of impact that we're looking at. Now, from there, of course, the business impact doesn't come true until you can deploy it. So we actually put it into our product, and this is our product actually explaining COBOL code in the actual recently released IBM watsonx Code Assistant for Z. That's actually where it's in action. That is the model that is being used. So driving real business value, we actually sell this stuff. And Instruct Lab's available as an open source technology right here. Last step, I am running out of time, so I'm going to step through this a little bit quicker, is how do you scale the innovation that you just built? You have a model that now has your data. How do you scale that? And this is what we've done. And again, open source technology for the most part. First, we created the bare minimum bootable AI runtime so developer can boot this up on their own machine and start experimenting with InstructLab. Single machine. When your developers begin to do things and actually discover the power, they can move that to an enterprise scale, leveraging Red Hat OpenShift AI. You can now use a cluster to build larger models, to iterate, to actually add more data into that mix. Beyond that, we've built a full tool chains around watsonx, our AI build platform, to take that model and start to create actual AI products with it. Deploy it in scales, monitor it, make sure there's trust and transparency all built in. All of this platform is designed so that you can take what the enterprise data and drive business value out of it. Now, my final slides. I'm going to close with the beginning statement. The future of AI is open. In the video, you saw that in IBM, we actually truly believe that to get the most out of AI is about collaboration. Collaboration, and it's also about trust. And open source can help promote innovation. Nothing better than having tens of thousands of developers looking at the code because they want to, because they're a community that want to innovate, and they contribute. They're driven. They're not necessarily paid to do this. They want to do this. Those guys are going to build innovation faster than any company. History has shown that that is actually happening. And by keeping that open, it means you can trust the model. You've seen the model algorithm. You've seen the data set. It means that it's clean for you to build on. We indemnify you against any copyright and IP issues. Really big part. And then we want you to get, because we are at IBM, we really think about technology for business. Not so much for consumer, for business. Which means I need to help you take your enterprise data and incorporate it into foundation models so you can drive new values. I need you to take your customer demand information and build it into a new time series model to help you predict customer demand better. That's what we want to do, and that's why we created InstructLab. It's open source, so you can use it, you can trust it. Now, hopefully that inspires you guys to co-create with us a little bit more. You can always engage my team here in Thailand for co-creation. With that, I'm already way over time. I'm going to say goodbye to you guys and hopefully catch up with you later on. Thank you.